Welcome back. Today we're going to be discussing lesson 17, two topics, subscripted variables and then angle relationships that are going to be very similar to system of equations. So before I get into subscripted variables and how those problems work, I want to make sure that we remember what those look like. So subscripted variables are going to be things like R1, T1, N of N, number of nickels, number of dimes, number of quarters. It's situations where we don't want to just write N, D, and Q. We want to remember it's a number of nickels, a number of dimes. And then these are when we're dealing with distance and rate and time. A lot of times with these situations, we'll have two different cases, two different scenarios. And so to differentiate them, we don't want to call both of them rate and time. We want to say the rate of the first, or the rate of the eastbound and the rate of the westbound. So that's why we do subscripted variables. So let's look at a practice problem. Okay, so our first example is dealing with number of nickels and number of dimes. And this is really your book's way of slowly introducing the concept of these word problems that are going to have this type of information. So they want to get you used to seeing two equations set up like this before they start giving you word problems where you're going to have to extract information and build your own equations that look like this. So just know that this has a purpose, a long-term plan. They're playing the long game. But with this, when I see this, I instantly think, awesome, I can solve this in my calculator using the system equation program. If you need help remembering how to use that program in your calculator, there will be a link in the description below. But with this, I don't have to use the calculator program. I could also use substitution. The only issue is right now, nickels and dimes are on the same side of the equal sign. I would need to isolate one of those variables, which can be done very easily by just subtracting. So we could say number of nickels equals 40 minus number of dimes, because I just subtracted number of dimes to the other side. Then I could use this to plug in here and solve using substitution. Important thing to remember if you are going to use your calculator is that our calculator only refers to X and Y. So if you're putting this in here and you get your answer, it's going to say X equals blank, Y equals blank. Don't write X equals blank and Y equals blank on your answer sheet, because that's not what they're asking for. They're asking for a number of nickels and number of dimes. So the way that we figure out what to write is number of nickels is occupying our X spot, because with these equations, it's always X plus Y equals our constant. And so whatever it says for X equals, we know that that's actually going to be number of nickels. And whatever they say Y equals will be our number of dimes. And that's all you got to do there. And our second practice problem, they have four different types of variables. We have R of M, T of M, R of W, T of W. And what we have to remember is we can have as many variables as we want to, but if we're going to solve, we have to have an equal number of equations. So here I have four variables, but I also have 1, 2, 3, 4 equations. So I know that I can solve for all of these variables. And what we're going to do is we're going to use these three smaller ones, and I always call this long problem my mastery equation. And we're going to plug these three into our mastery equation and solve for the remaining unknown. So we're going to replace R of M with 40. And we're going to replace RW with 60. But TM and TW, neither of them are isolated. And so I'm going to need to choose which one I want to solve first. So I'm going to say TM equals 5 minus TW. And now I can use that as substitution right here. So this one, TW, is going to stay as is, and it's going to be the first thing that I solve for. So we're going to distribute 40 to 200 minus 40 TW plus 60 TW equals to 60. We're going to add our like terms, which will be 20 TW. And I'm also going to subtract this 200. So we're going to get equals 60 divided by 20. So TW equals 3. We're halfway done. The only other variable here that I don't know the solution to is going to be Tn. So I can take 3 and plug it in right here and find out what Tn equals. So Tn will equal 5 minus 3, so Tn equals 2. So on my answer sheet or whatever, as I write this answer, let's say this was problem number 5, I would say Tw equals 3, comma, Tn equals 2. And that's it. We're done. Okay, so the second part of this lesson is going to be dealing with angle relationships. So here we see that we have two parallel lines intersected by a transversal, and they want us to solve for x and y, but notice that for each of these missing angles, they both have x and y. So it's not like before where it just had x or just y. Now they have both. So if we have two variables, that means we're going to need to have two equations. I do know that this angle is 50, and because I know about corresponding angles when dealing with the transversal, I also know that this angle is 50. So there is one of my equations right away. So we have 5x minus 10y equals 50. I also know that if this angle is 50, this angle should equal to be 130 degrees. So now that I know that, I have my second equation. So 7x minus 2y equals 130. And right here, as is, I can plug it into my calculator and solve. So that's it. That's all you have to do is just find a way to create two equations because you have two unknowns. All right, and that's it for lesson 17, where we're talking about subscripted variables and then angle relationships dealing with system equations. Be sure to check out the details below so you can get those links on how to use those calculator programs to make your life easier. I'll see you guys in class.